So now let's go back and look at the first program we looked at. So here what we're doing is we're statically allocating x, and then we're statically allocating x pointer, and then we're making x pointer point to x. I'm sure you're probably wondering, well, if I already have x, why would I need this second pointer? Great question. So now we're going to look at a way of dynamically allocating objects. So let me copy this program pointer 0 to pointer to a.cc, and I'm going to have two versions of these. So now instead of statically allocating x, I'm going to get rid of it, and I'm going to dynamically allocate. And as we saw in the video lecture, using the new command, new will dynamically allocate an object. It will call the constructor, and then it returns the address of where that new dynamically allocated object resides in memory. So if I'm going to do the exact same exercise, now what I can do here is I've created a pointer, and in this assignment statement I'm dynamically allocating an integer. I am passing 5 to its constructor, setting its value to 5, and then the address is being returned and then stored in x pointer. So now what I can do is, by dereferencing the pointer, I can access the value, and I don't have a name for that object, that dynamically allocated object. Like I had in the previous example, it was x. Well, there is no x now. I only have the pointer to the object. It doesn't have a symbolic name. And as you know, once you've dynamically allocated an object, then you have to deallocate it using the delete command. All right, so if I run this, this should just print the value 5. And that's what I get. So now let's look at an example that involves class objects. So here I have a similar program. What I'm doing here, though, I have a point class. This is very stripped down, very simple, with two private data members, x and y. And then I have an explicit constructor that will let me pass in values for x and y. And then I have a simple print method, and the print method is just going to print out a point as we would expect to see it in some sort of a Cartesian coordinate system. So let's look at a comparable example here. Now, if I were going to do this statically, right? So I would say something like point P, pass in 3 and 4 for x and y, and then I can call the print method on point P. So this should print out 3, 4 in a coordinate representation. And that's what it does. Now if I want to do this using pointers, first of all I have to declare a pointer to a point, and I have to use new to dynamically allocate the point object, just like that. So again, what this is going to do is the new command is going to allocate space for a point object. It is going to pass 3 and 4 to the constructor. The constructor is going to execute, assigning 3 and 4 to the private data members x and y. Then new is going to return the address of where that dynamically allocated point object is in memory and assign it to P. Now what I've done here is I've done this all in one statement, but if we wanted to go back and do something a little bit more piecemeal, then we can do that. Here we're creating a pointer to a point object, assigning it to null, and now we're dynamically allocating a new point and setting it. Then we have to remember that for every new there has to be a delete, so we want to delete the point object. that we just created. Now what happens if we want to call the print method? So there are a couple of things. If you try to do this, you're going to get a syntax error, and I'll explain why. So let's just take a look at that. Notice that it tells me that I have an error and I've requested a member for print P. Well, keep in mind that P here is not a point object, it's a pointer to a point object. And this pointer P does not have a print method. What I need to do is I need to dereference the pointer. That will give me the point object, and then I can call the print method. Well, how do I dereference a pointer? I use the asterisk. Now this is not going to work either, but let's take a look at the error message that we get. So again, it's telling me that it's giving me the same message, so something went wrong. If you look at the precedence of operators, you notice that the method selection operator, the period, the dot in this case, has a higher operator precedence than does the dereference operator. So what's happening is I am still doing this. I am still doing the same thing. I am trying to call the print method of a pointer. What I need to do is I need to use parentheses to alter the order of evaluation by writing this. Now what will happen is by putting parentheses here, I ensure that the first thing I do is I dereference the pointer. That gives me a point object, and then I can call the print method on that point object. So this should compile, and when I run it, I get 3, 4. Now this syntax is a little cumbersome. There is an alternative form of the dereference operator that you use for class objects, and instead of writing this, you can write this little pointer notation, which is just the dash and the greater than sign, as an alternative syntax. And so what this does is this dereferences the pointer P, I get a point object, and then it selects the print method. So it's equivalent to the previous statement. So again, if I compile this, I should get 3, 4 again. And that's what I get.